Imagine you're using a grocery delivery app and you type in ice cream. You hit enter and the screen tells you there are 0 results. You know they sell it. The problem is that the store's inventory system only lists Sundays. Traditional relational databases organize information into rigid rows and columns, and their search function works like a strict spelling test. It scans the grid and rejects the Sunday cell because the letters don't perfectly match your search. That strict sorting is useful if you need to pull up a bank balance or an exact order number. But today, most of our information is messy. We are dealing with long text documents, images, and audio files. To build modern artificial intelligence, computer scientists needed a new way to process all that disorganized information. They needed a system that could look past the literal spelling of a word and understand the actual context behind it. The limitations of exact match keyword searches in a world full of complex information led to the development of an entirely different tool, the vector database. To give a machine the ability to understand context, we first have to translate abstract concepts into a language computers natively speak, sequences of numbers, which are known as vectors. A single word turns into an array of numbers, and then those numbers act exactly like GPS coordinates, flying into a massive 3-dimensional grid and plotting themselves as a glowing point. Because these coordinates represent meaning, context creates physical proximity on the map. A picture of a cat, an audio clip of a meow, and the text for the word kitten are all assigned coordinates right next to each other in the exact same neighborhood. If we introduce a completely unrelated concept, like a text document about a car, the math pushes it far away, landing miles away in a completely separate sector of the map. By translating information into physical locations, the AI creates a literal landscape of meaning. On this map, physical distance equals conceptual relevance. When a user enters a new search term, like feline, the system converts that word into a new coordinate and drops a pin directly into the center of the existing cat-related cluster. The database doesn't scan for the letters F-E-L-I-N-E. Instead, it relies on geometry. It physically measures the distance from the new search pin to the closest data points on the map. The system then retrieves those specific points simply because they are the nearest neighbors. You get accurate results, even though your search term shares 0 keywords with the files it found. By shifting search from a spelling test to a geometry problem, these databases give AI a way to find information based on our actual intent. Artificial intelligence models are prone to a problem called hallucinations. Chatbots confidently invent false answers because they lack access to specific, factual knowledge. Let's look at a practical scenario. Imagine an employee asks their corporate human resources chatbot a very specific question about taking time off to have a baby. The chatbot takes that employee's question, turns it into a coordinate, and searches the company's internal vector database for the closest match on the map. The database retrieves the company's official parental leave policy document because its mapped meaning aligns with the coordinates of the question. The AI reads that specific retrieved document and uses it to generate a factual answer. This process is known as Retrieval Augmented Generation, or RAG for short. In this setup, the vector database acts as the reliable long-term memory for an AI, anchoring its output in reality instead of algorithmic guesswork. While this technology is powerful, traditional databases are still the right tool for organized data requiring exact precision. You wouldn't want a system to approximate your password or guess your bank balance based on similarity. This side-by-side animated diagram highlights the distinction. On the left, traditional databases handle exact records. On the right, vector databases provide the infrastructure for managing messy, unstructured data, searching for concepts instead of keywords, and powering AI recommendation engines. A traditional database excels at retrieving a specific file from a digital filing cabinet. A vector database provides the spatial map that helps AI connect those files into a coherent thought.
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.